Welcome to the shop. In today's video, I'm going to be making the rest of the base for this sculpture that I've been working on, this Damascus style marine sculpture with a wood and metal base. I'm going to be making the aluminum parts, the aluminum legs that have my standard design element, the holes in a row with decreasing size. I'm also going to be making a lamination of some pieces of wood using the same woods that are used in the bent piece that surrounds the glass. So now I'm starting the construction of the base for my sculpture, and just thought I'd show, it's not that interesting, but I thought just for fun that I would show you how I cut aluminum on the table saw. The table saw cuts aluminum exceptionally well as long as you're careful and use the correct tool and the correct technique. This is a thin kerf aluminum cutting blade specifically designed for aluminum with the right tooth geometry, using what's fairly close to a zero clearance insert. It actually has a little bit of extra space in the back. I'm using the DRO, which you can't see in the video over here, to get my dimension. These parts that I'm making are really tiny, and you don't want to even get a finger anywhere near close to these, so push sticks are our friends. Also, you probably can't see in the video, I'm wearing safety glasses, and keep fingers far away, and just be aware that if the blade catches and it kicks, it's going to fire backward. I'm wearing a shop coat. So far, I've never had a kickback on aluminum. Notice that the push stick also has a fairly long protrusion. This allows me to create downward pressure on the leading edge of the piece to keep it from popping up as it hits the blade. Also, I use two push sticks in this kind of an arrangement to make sure that the piece stays up against the fence, because the action of sawing tends to pull the piece away from the fence, and I want to get a nice accurate cut. Of course, this is just a blank, and it doesn't have to be accurate. It just needs to be bigger than the final piece. But I don't want to waste a tremendous lot of material and have to, throw away a whole lot of the stuff around the edges. So I usually make my blank about 60 thousandths or so over the size of the finished part. And it really depends. For a part like this, who cares? It's just scrap aluminum anyway. So apply a little lubricant, a little bit of WD-40, and pay attention. This is not an operation that can be done safely if you're distracted, thinking about something else. This one, pay attention. Stop thinking about the video. Stop talking. Pay attention. And thought I was going to get two pieces out of this, but I don't think so. Might have to get another. And of course, this gives me the opportunity to show how the fence can be used when cutting aluminum. I actually prefer doing this as opposed to cutting it out of a sheet. I actually prefer cutting from an extrusion, and most of the parts for the Inquala are made of extrusion, and many of the operations are done like this. So stop talking, pay attention, be safe. I keep the piece in control all the way to the end because the back end of the blade is the dangerous end. So it's not safe until it's well beyond the end of the blade. I can't get kind of confident when it's in the middle and go, oh yeah, the cut's finished, I don't need to pay attention. Yeah, it's not safe until it's way beyond the blade. So blanks are cut. Not very exciting little blanks, but hey, it's what the job requires. So we headed over to the Bridgeport. Before going to the mill, I like to just roughly clean up, deburr, clean up, get them roughly nice. It's so fast. I've got the Scotch-Brite wheel very close to the Bridgeport, so it doesn't take any time at all just to knock off the little saw burrs. Also, I've got the thing mounted at a reasonable height for me. A lot of tools are designed for shorter people, and I don't like bending over, so I try to make all of my tools where the working area is right about at elbow height with the arm kind of horizontal and parallel to the ground. I'm going to be using the Bridgeport 2-axis to make the little legs, and yeah, they're small and they're not that interesting, but you know, just to be complete, I'm putting it all on video. So, standard operating procedure. Grab the Heimer. Even though I zeroed the machine before turning it off, the Heimer is just so fast. The control computer, the control screen for Mach 3 is a touch screen, which is actually convenient at times, makes things a little easier sometimes. So now that I've got my zero set, go over here and do a quick sanity check. Make sure that zero really is zero. Jog over, Heimer out. Except in very special cases, I always put my zero at the left backside of the vise, and it works in almost every case. So just using a little piece of aluminum to align this. Once again, this is art. This is not precision work. So it doesn't have to be the most accurate piece the world has ever seen, but still, hey, I got a CNC mill, well, I might as well take advantage of it. So I'm starting out here with my first hole, and the smaller holes in my design can't be milled, they have to be drilled, and the larger holes I tend to mill. So I'm going to drill the first 2 holes, and I forgot what the sizes were. I should have put them in the tool path, but let me go get my piece of paper. My first hole is going to be a letter drill, a size A, and over here in my drill collection, I've got my letter drills, number drills, and fractional drills, and they're all the stubby length. I like the stubby length because I can pretty much, in most applications, get by without a center drill or a spotting drill. If I'm really trying to get the most precise hole possible, I'll use the full method, the center drill, the undersized drill, the ream. But for probably the majority, the vast majority of the work I do, the stubby drills are just fine. Also, I don't use a drill chuck. I have one, but it just sits here in the corner and mostly unused. I usually use collets, and I have my collets are graduated in increments of 30 seconds of an inch, and so pretty much any size will fit in a collet. And since the stubby drills are the same length, roughly the same length as milling cutters, I don't have to keep constantly getting my knee up and down. So I've got the mist coolant on a foot pedal. Just slowly peck drilling, and as long as I have that drill in place, I'm making 2 parts. I might as well just do the other part. And sometimes I do all the operations on one part, changing tools before taking the part out, and sometimes I take the part out. It just depends. So the next one is going to be a number 21 number drill, and go over to my number drill index here. Once again, stubby. These are all cobalt. High-speed steel cobalt drills, and I've had really good luck with them. So, on to the next hole. Power drawbar makes it so fast to change tools. I can change tools faster with my collets and power drawbar than I can with a keyless drill chuck. So now I'm putting in a 1/4-inch milling cutter, and the next 2 holes are going to be milled holes. And even though it's not necessary, I'm going to set my Z. If I was in production and I really cared about maximum performance and the fastest possible result, I'd probably try to do this in one pass, but I've had problems cutting a profile, just a blind profile with a 1/4-inch bit, a 1/4-inch milling cutter in 1/4-inch aluminum with the chips clogging up and breaking the cutter. Sometimes it does, sometimes it doesn't. It's all about chip evacuation. So, hey, I got time. I'll do it in 2 passes. Quick sanity check, just to make sure it's not crazy. So back to the beginning, this is a pattern that has 2 profiles with a rapid in between, so I have to always remember that I gotta have the Z-axis raised before the rapid. So might as well just set the quill stop, makes things a little faster. So now, checking to make sure that I don't bite my parallel. I move the parallel out a little bit just to make sure that I don't bite it with the milling cutter. I've also got the mist coolant on a switch in addition to, notice that I avoided making a mistake there. If I would have pushed the start button at that point, it would have ruined my part. I've also got the mist coolant on a toggle switch for those times when I just want to leave it on. So now there's my standard design element of the hole pattern, and next step is to make a tooling plate. I use tooling plates for just about everything I do. It's a very, very convenient way to hold the workpiece, using 3/8 aluminum for the tooling plate. And I'm using trying out just to see. Usually, in most of my work, I use a 3-flute cutter from Lakeshore Carbide, solid carbide, zirconium nitride coating. I'm trying some slightly cheaper Chinese 2-flutes from Amazon, and I'm going to see how they perform. So I'm going to be loading up my fixture drilling program, and my first hole is going to be a 1/4 20. I've got all of my taps and tap drills in a block, all labeled. So I have the tap drill for aluminum, 75% thread, the tap drill for steel, 60% thread, a slightly larger clearance hole, and the tightest hole possible to clear the shaft of the screw if I want the tightest possible fit. So I don't have to keep looking at the charts. I just go over here and there my sizes are all in place. So the tooling plate is going to have a 1/4-20 and a 632 hole. The 1/4-20 obviously is going to be for the larger hole. The 632 will be for the smaller hole. And since my hole sizes were chosen to be an artistic pattern, they're not precisely screw shank sizes. And so for the 632, I'm going to use a flathead screw, and for the 1032, I'm just going to use a washer, and my tooling plate is the same width as my blank, and so I can align the piece in this direction. The 632 flathead constrains it about that point, so it's free to rotate, and then if I get the sides lined up, I'll be okay. In my more serious production-oriented work, making parts for the Inquala, I'll machine a little spacer that has all the sizes correct. So sometimes if I really, really care about making my tapped hole precisely perpendicular, or if I'm using a large tap, I'll do power tapping on the Bridgeport, but for quick and dirty tooling plates, I got a really good eye for perpendicular. Works really well to do it by hand. Just hit these a little bit for a tiny bit of deburring. Then hit the back side of them a little. Using these Noga hand deburring tools, and they work really well. So I'm going to put the 632 screw in the small hole, then lining up the part, and put the 1/4-20 screw with a washer, which I've already verified on the CAD system that the washer will clear. So, going over here to load the profile. And once again, I'm going to be using the 1/4-inch Chinese end mill. Setting 0. Perform the safe sanity check, observing that yes, we do have clearance, and if we don't have clearance and we kind of kiss that washer, yeah, who cares? Assuming that the mill will take care of it. So there we go. Let's start it up. Once again, doing it in 2 passes. Going a little bit deeper than the part, just to make sure. Sometimes the stock isn't exactly 0.25, so I usually do 10 thousandths over just to make sure that I get a clean cut, and I do. And there we have a completely successful little part. So that's what the little guy looks like. Get it over here. So let's do it again. As I've said in previous videos, the 2-axis milling on the Bridgeport is so fast for doing one-off parts, for doing, you know, onesie-twosies. It's really quick. When I'm in production, when I'm concerned about cycle time and want to get a lot of parts made, for example, when doing a Impala production run, then nothing beats the Tormach. But for these quick little projects, the Bridgeport is so much faster. And that completes the milling of the little aluminum legs. The next step will be to go back over to the table saw and the bandsaw and the drum sander and make some little homemade veneer pieces for the laminated base. Okay. Clean up the work area a little bit. Send the machine back to 0. And who knows, maybe someday I'll use this tooling plate again if I make more of these guys.